Hello guys, today I will show how I write the contest in the codeforces. It's a platform for competitive programmers. Today we'll be writing codeforce round 11, 12, and I'll be in division 2. Why not in division 1? Because division 1 is for those who have rating more than 1900, but mine is just 1579 and my peak was at 1828. Yeah, that was when? It was 21st of March. Yeah, 21st of March this year. So you participate in contests, you solve problems, and you gain rating. Just like in chess, you like play with another player, and if you win, you gain. If you lose, your rating is decreased. I will be here participating with many other people. Like there are about 26,000 people who also registered for this contest. I don't know if writing is the right word to use, because in Russian writing is a proper, like writing, when we say writing we mean like participating in contest. So basically I will solve problems, I will maybe talk about the solution, how I did it, maybe afterwards, maybe during the contest. So let's start. We're very excited. Okay, let me make it English so most of you could understand. So there are n plus 2 positions, number from 0 to n plus 1. Initial position I contains an element of weight wi for every unit, while positions 0 and n plus 1 are empty. You choose an integer k, then every element moves exactly once simultaneously. If wi is less than k, the element of position I moves to position I minus 1. Wi greater, the element of position I moves to position I plus 1. If wi is equal to k, the entire movement process fails immediately. An integer k is perfect if the movement does not fail, and upon completion, every position from 1 to n contains exactly one element. Every position from 1 to n contains exactly one element. Okay, determine whether perfect. Determine whether perfect integer k exists. Interesting. Very interesting. So here 1 and 7, there's only one element, and if you choose some element, it will move either left or right, and it's not going to work. Oh my gosh. Okay. So here we could choose k is equal to 2, then this will move here, and this will move here. So we need to choose such number. Okay. Such numbers that they will like swap with each other, and if such number exists, I think if n is odd, then the answer, there is no answer. Okay. So we check if n is odd, and the answer is no. And also we check every two elements. If AI is less than or equal to 1, then it's not suitable for us. Otherwise, I want to find the minimum and maximum. And then check if their distance is bigger than 1. I could not explain it in details, but it should work. Okay, why it's not working then? Oh, okay. This should work. Yeah. You're given two integers n and k. Construct a binary string s with length n such that both of the following conditions hold. The absolute difference between the number of characters 0 and the number of... Oh, did I start recording? Okay. So the difference between the number of characters 0 and the number of characters 1 in S is at most 1. Okay. There are exactly k pairs of... There are exactly k pairs of adjacent equal characters in S. Okay, formally there are exactly k indices such that they're equal, yeah. Or determine that no such string exists. Okay, we have to make a binary string, okay, such that the equals, number of equals is exactly k. So yeah, let's think about it. And also the number of zeros and ones are half. So let's look at the... Maybe I should type here to make it easy as well. Like, let's consider the n is even number of zeros should be is equal to n divided by 2, and the number of ones as well, n divided by 2. Then to construct uh, construct the number of equal elements is equal to k. What we can do? We can translate the problem, and we can make the number of unequal elements is equal to n minus 1 minus k. Number of not equal elements. Okay. Okay. Let's look at this case, for example. Okay. So let's imagine that we have already a string. We have like compressed string, and okay, and let's its size should be k plus 1. Then if you compress the string, size should be k plus 1, and we can see that number of not equal elements is k. So wait, in the case of odd elements, they should be almost the same. Okay, let's do like this. Uh, okay. Now I have done rating. I hope it's correct. Here, 1, 2, there are 2. Here, wait. Something is off. Something is off. Why I have 0 and 1? Oh, okay. 0 here. So 1, 2, and then 1. Okay, only 1. 0. Okay, not. It has to be correct, I think. And I will explain it in more details of the contest, or maybe in the next video. Okay, here given an element arranged in line. Okay. You may delete any number of elements, then remaining elements form a subsequence, and keep the relative order. Let the length of the set is going to be n. The element with original index I becomes j's element of the subsequence. Define its left rank as j and its right rank as m minus 1 plus j. Okay, for each element you are given 2 integer segments. The ith element is valid in subsequence of length m if and only if when it occupies position j in the subsequence both of the following hold. The left rank is not in the range. Left I, right I, and right rank is not range. Subsequence is valid if every element remaining in it is valid. Find the maximum possible length of a valid subsequence. The answer may be 0. N is 5000. Maybe some kind of DP. We can easily do dynamic programming now. Is it that easy? Or oh, we don't know the size. That's the problem. We don't know the final size. So yeah, it's a little bit tougher. Okay, J is it to check. Let's look at left eye, right eyes. Okay, okay. The length of the valid subsequence. Okay. The best we can do so far is write the dynamic programming on n cubed, like ijk if for prefix I, length j, and we are on case element. Or maybe we fix the prefix and the size, and we would store the How many elements we have? What do you think? Like dpij would store the maximum element so far. Can we do that? Oh, let me think. Suppose the answer is t max subsequence. T is the max, and we would have something like I1 in indices I1, I2 up to IT, and each of them would follow the property like down. Like J is not in L IJ and right IJ. And also T minus J plus 1 is not in QI UIJ BIJ. Like what if we fix T and I don't know, can we like change this equation? Like suppose that tj plus 1 is between them, is between uij and vij, then we can subtract t from both sides. Uij minus t, I'll subtract 1. j minus t minus 1. We can multiply everything by minus 1, and what we get is we would be here, so what becomes t plus 1 minus vij t plus 1 uij. So that means j should not be in j should not be in t plus 1 minus vij and t plus 1 minus uij. Okay, that's quite nice. This didn't help. I'm very stuck. Very stuck. Can we bin search the answer? That would be nice. Like it would be 5,000 by 5,000 by 5,000 curve into 5,000. It's 3 seconds. Maybe it will pass. Just maybe. It's not even 5,000, it's I think it should pass. Very likely. What's happening? What's happening? What's wrong? abonnement. Look at how many people solved it. Over 1,000, man. And I could not solve it. I can't solve it. Why? Oh, I got an idea. Let's check. It's gonna work. What? I'm in shock. Okay, as I see, the D is going to be really hard. As I see from the number of people that solved D. Anyways, let's try. Okay, your integer array have length at -1. Or permutation B of length and define VI. It's the minimum of the all maximum PJ and up to I and maximum of PJ of the rest, and this is VI. Yeah. Oh my god, you just count the number of permutations P of length n such that VI is equal to AI. Oh my god, that is actually freaking nasty problem. Let's see which place I am. Oh, thousands. That's good. So my friends are 700. If I could solve it earlier though. Yes. I really want to solve D to Aura farm. Okay, I'll be back. Because it can turn off if I do not do anything. You can actually watch my YouTube. Okay, watch some Clash Royale.
In today's video, after every single time we lose a Clash Royale game, we have to eat a spicier and spicier food. We got our first match up against Remy Eli, and he's actually running bait, which is pretty surprising because he normally is known for always playing minor magic archers, so I guess he's running a little different deck here. I think he probably still has magic archer though, because this type of bait deck usually does have that. I'm gonna go for a giant skelly into the Valkyrie, but I do have to be careful of a possible magic archer, so I'll have like a wizard ready to get onto that if necessary. Yeah, I mean, he very well could go for it.
Or maybe not.
I'm pretty sure he has magic archer and not like a dark goblin. Oh, he actually does have a dark goblin. Okay. Anyways, guys, yeah, in today's video, our spice is gonna scale after every loss. So after the first loss, we're gonna just have kind of like a light spice thing. And yeah, after every single loss, it's going to get hotter and hotter until we have like the hottest possible thing. And the food that I ordered today for us is this place called Dave's Hot Chicken. It's in the US, I think Canada, probably a few other places too. I'm sure some of you guys have seen it or heard about it. And yeah, it's known for being very spicy. They have like 6 different levels of spice. So yeah, I mean, we're going to probably try the Reaper spice level at the end of the video, which is the very spiciest thing possible that they have. And yeah, it's gonna be tough, guys. I'm just not really that good with spice is the issue. I just feel like sometimes if things are too spicy, it takes away from the flavor. I don't know if you guys agree with me on that, but yeah, sometimes I feel like things are just so spicy that you can't like enjoy them, you know, because like it's so spicy that all you taste is the spice and not the actual flavor of whatever it may be. You know what I mean? Like, for example, for chips and stuff like that, like, sometimes they're just, like, too spicy that, like, you can't really enjoy the chips. You just taste pure spice. I don't know. The most spicy thing I really ever eat was, like, sometimes in the past I'd have, like, these fake Talkies from Trader Joe's. Like, they look kind of like Talkies, but they're healthier and stuff type deal. Anyways, guys, we are kind of losing this match so far, but I feel like if we make a good enough push, we have a good chance to do something here, maybe. Okay, he does actually go for a rocket. That is crazy aggressive. Somehow I feel like he's going to get away with it, though. Alright, I think what we got to do is get a really good wizard here, maybe, because he, yeah, he wasted the rocket. He's in trouble. Yeah, we get our ram on the tower, guys. This is going to be a good amount of damage here. He needs to get a Valkyrie down. Okay. Our wizard is getting hit by the tower, so I guess there's no point to pop the ability right here, but pretty happy with this. We can just get a ghost here up high, get vines for this. I think that should be no damage on our tower. Yeah, perfect. Alright, what is he gonna do here? Okay, he goes for the goblins. I'm actually gonna Evo Ram other side just to force out his elixir, I guess. Okay, he's going in again here, but we have our giant skelly and everything, so it should be no issue. Okay, the Dark Goblin does die. I'm just gonna ignore the right side, because we have so much HP there anyways, so it doesn't really matter. Okay, wait, guys, I gotta be careful not to lose. We are at top ladder right now, and I'm not playing my main deck. I'm gonna kind of play just random different decks throughout the video, because I gotta nerf myself, bro. Like, if I only played my main deck, I'd obviously win, like, every single game, so I gotta sometimes switch it up a little bit. Those wall breakers better die. They better die. How did that connect? How did that connect? Yo, there's no way that just connected there. Okay, guys, we gotta be careful here. Man, I feel like we could win this one, but we gotta be so careful. Yo, I need to get vines down. I need to get vines down. I need to get vines down. Oh my gosh, okay. We get a couple piggies up in here. We could go for a battle ram as well. He does waste the ice spirit. Does he have anything for this ram? Yo, the ram! Nice! Wait. Oh, shoot. Oh! Wait. It's not gonna get enough damage. Wait, I could just Vines arrows the tower, but I gotta... Oh my gosh, I just... Okay. That was like the biggest sell of the century. But now I get to eat spicy food. Okay, guys, so we got our mild spicy item, which is a mozzarella plank from Dave's Hot Chicken. Maybe with like a pickle on here. Hopefully this doesn't go too badly. True, that is a little bit of a kick, but honestly, that's not that bad, guys. That's not that bad. Honestly, guys, I was pretty surprised that that chicken, or not chicken, I mean mozzarella stick wasn't more spicy for me. I guess because it was just mild. I mean, it was only tier 2. Mild is only tier 2, so I guess it makes sense. Mild doesn't sound very bad at all, even for someone that's not like super into spice. But guys, it's only gonna be a lot harder from here, so I gotta just be thankful that I had one food item, which I kind of enjoyed, but I don't know if I'm going to enjoy the rest of these very much. Anyways, we are playing Hog Executioner here instead of like my normal type of hog deck. Kind of wanted to give this one a try. Some people were recommending that I play this in a video, so let's see how we end up doing with it. I feel like we have some pretty good cards here against recruits, but at the same time, he does have good double lane pressure. We can defend in one lane well, but I feel like if he pressures well in both lanes, it could still get a little bit interesting. We're gonna definitely have to abuse our Evo Xe though, and I'm sure our Evo Valk can get good value as well. I kind of noticed after I ate that spicy thing, even though it was mild, my nose feels like it's almost a bit runny
Okay,
right now or
guys,
something like
I'm
that.
back.
I don't know. Not exactly
I'm
runny, but
black.
like
No, actually, I'm white, or maybe I'm the mixture. So, we got to the point. I got to the point where I usually give up because there are not many people solving D, and it means that it's hard. Also, we can notice that the time limit is greater, like this 1 second, 1 second, 2 seconds, and usually we're given 2 seconds to solve the problem, but this one is 4 seconds. I don't think that its solution will be this very complicated data structures, but okay, we'll try to solve it. I need my okay. So the VI is the minimum from the prefix maximum pref I and suf I plus 1. Pref I means the maximum element from 1 to I. Suf I plus 1 means the maximum element from I plus 1 to n. And it's also a permutation. What we know about permutations, that the elements do not repeat. Like if we got a permutation of size n, each element should be from 1 to n, and all of them are different. All of them are different. Like for 2 pairs, there's no like similar. Okay, we got our condition, and we need to count number of suitable permutations. Okay, modulo this. There could be a lot of permutations. Like here's the 12. Why is it 12? Okay, it is 12 because from one side we got 4, and the other side could be, and from this side we got 5. Yeah, so that's why it's 12. Or no, wait, if you like fix these two, we can also like swap them, and between them we can put anything. and it will not change. Okay. Like when every single element is equal, that could mean several things. Like for example, this one, it's dissimilar. Like this one, we got 4. We got 3 from one side and 4 from the other, and the elements between, it doesn't matter what we put in between, this property will hold. So, and we can also swap them and it'll do the same. Yeah. What about this one? Okay, this one means that starting from 3, we got 5. Oh my gosh, I should think of what shape it would be. What shape will be our answer? Like, I guess that it would first grow. Like it's like mountain. It will be like mountain, like this. So we got no point where like we have 2 greater from both sides, because it's impossible. So this case is impossible. We can have this case or this case. It's fine. Or this case. So we can also notice that before that it was 3 and it changed to 5. So that means a lot, because when we got here, we met 5. Like we met 5. I think that the third element should always be 5. Why? Because it cannot be other element, because we actually cannot be other element. If it's on the right side, that means that this side, no, it cannot be, I think. And this also means like we got the 6th element is the last element. We got 3 here. What? And also, why it's 3 here? Let's think. Okay. Let's take some example permutation exceeds properties. 4, 3, 5, 2. So it will result in like 1 and a little bit 4, a little bit 4 again, and 5. And no, it's not 5 here. It's actually 2, just 2. So what can we say about equal elements? We got AI from one side and AI plus 1 from the other side. So is it always so or no? Can we look at the bigger example, like okay, I got an idea. We can open some file. It's often useful to check some examples and look at their properties. Once I solve problem with that approach, okay, also got this interesting function method, chrono steady clock, now time since epoch count. We got interesting method to generate random numbers. R&D left right is uniform int distribution int left right. Okay. X, okay, while used X, okay, we would assign its random number again, pi is equal to X. Okay, let's create pref and suf. So these are the pref and so I was talking about, and we have to output this one. I should type like this. I mean pref for sub y plus 1. Let's see. Also, let's print our n. Let's print our permutation p And let's see our results here. No, it says I have no AI, so I type PI instead of that. So let's generate some validation size 10. Interesting. Interesting. Let's do something less than 10. I got an idea. Okay. It's nicer this way. So the first A0, A1 means the first element of permutation, always. Or no. No, actually, not always. The first element cannot be, obviously cannot be n. Actually, any element cannot be n, because we always got a smaller one. Some elements more than n. So see, like I got this chunk of 8s, and it's between 9 and 8. I also got these 7s, 6, 7s. And I got 4 because it's the smallest. Let's look at 8. So what's needed to pay attention is this. I got 7 and 8. Like between n and n minus 1, all of them are going to be n minus 1. Yeah, that's pretty trivial observation. Trivial. So there always exists the n minus 1 chunk. Then let's look at the other chunks. In the n minus 1 chunk, it can also be like, they could be swapped. They can be swapped, and it will not change the answer. Let's look at the others, like this 6, for example. In the beginning it's 6, 6. Okay. Let's get some more. 15. Here it's a little bit messed up. So again we got n minus 1 chunk. The n minus 1 chunk is between 14 and 15. You got 13 chunk. Oh, I start to feel the pattern. I start to feel it. Like we always have n minus 1 chunk, and from that on, like it divides into two sections, and it's always decreasing. Okay, that's very interesting. So then the solution is like this. Okay. We need to find our n minus 1 chunk, and from that it just would decrease. It's just like volcano. It would not strictly decrease, but like this. It will go like this. Like, let's this be n minus 1 chunk, and then it will go like this, then like this, like this, like this, and also go like this, like this, like this. And these are fixed. Like, elements in this position are that elements. So you got, yeah. So what do we do with the elements in between? In between that elements. We get these elements and we put them in some array. And then we look at the elements. Whew. Let's look at some example one more time. So here n minus chunk is closer. Let's look at another example. So we got elements 4, 7. Let me take screenshot. 4, 7, and so on. Like I put these 4, 7, 12, 13, and also I got 10. No, let me divide them actually. 13, and I got from the other side is 10. So 10 could not be here, and these elements also could not be here, but others can. other elements except them can. And 14 and 15 is the other, like the other chunk. So what elements left are 1, 2, 3. Let me just text 1, 2, 3. There's 5, 6, 7. There's 7, 9, 10. We got 10, 12. No, we got over 12. So these elements. And we can see that, oh my god, 13 is so long. Like we can see 1, 2, 3, 4, 5, 6, 7. We can, instead of, we can put something in between these 6. 1, 2, 3, 4, 5, 6. Yeah, we can put something instead of these 6 elements, and there they should be. They should be less than 10, less than 13, I mean. So these elements are, include all of this. You can choose any of these from here. Okay. But we also care about other elements as well. Like in between them we can already cannot put anything, and we also can put like n minus 1 elements, like the number of -1, the size -1 elements here, so also 1 element here, and we can put this element should be, so let's put some constraints. In the first part, where all elements that are less than 13, so it's first pair, then goes 1 element less than 14, and then goes one element less than 10. And how many permutations we got? So if you can see, if we add this up, we exactly got this number. So we have to count number of permutations that satisfy these properties. They satisfy these properties. And these properties are, the first 6 elements should not be, first 6 elements less than 13. The next one element should be less than 14. And the next element should be less than 10. So we got, we paraphrased our problem. Yeah, that's great. It's actually great. So we could paraphrase. Now, how do we solve this problem? That's the main question. We have an hour more. I'm surprised. So we actually could solve this problem. Let's just log in and find the method to solve it. So this means that the only element that we cannot put there is 11, right? But in other cases we can put anything. So we can subtract. Like, actually, how do we do this? How do we do this? Shit. So this, like, if you look at the less than part, this is also like mounting, because these values we get from the array, and this will also be mounting. And some element would lie in, it definitely can lie here, and it would extend to some part of here and to some part of here. And we should count the number of permutations. Should be able to count. We can do it from top to bottom, from the greatest element to the lowest, and just minus this. Okay, I actually got how to do it. I'll actually, Pete, it's easy then. No? Okay. The question is, can we do it in time? Can we solve it in time? Okay. Actually got -1. First, yeah. We need to check like if the answer even exists. So let's divide it into chunks. Plus, okay. Two. Okay, I think I solved. Is the probability of 19%. The probability of 90%. Let's also delete these. Okay, let's check. That's correct. So I just looked at the properties and I solved. That's crazy. I didn't actually think that I would solve this. Yeah, let's go. How many solved? 40,000. I should have think faster. My friend solved. No, he didn't solve. No. And I solved. Okay. So let's read A. I have no hopes for this one during the contest, but maybe for the other time. For another time, maybe. This question is crazy. Like actually crazy. But the rainbow is solved in 17 minutes. He actually solved. Oh no. He didn't. I want to say he solved D slower than E, but he solved in 17 and he solved this in 16. So yeah, I'm actually going to be expert. This is my performance. And let's read F. freaking cool. Like, that's an interesting. Okay. Okay. That's uh I will return in like 10 minutes, okay? And then I will, I think, do the explanations for the problems. Maybe. Okay, I think that's it for today. I will do the editorial in the next video, I hope. And I hope you enjoyed. Okay, this is actually my first video of this type. I've done like a lot of recordings before. We usually recorded such kind of videos for like qualifications to some Olympiads, and yeah, this contest was very cool. I really enjoyed it. Okay, bye. See you in the next video.